Hello there, I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300ER. Tonight we're going to be flying the Airbus A320 214, so thank you very much for watching me. I'm in the cockpit of the Airbus A320 214 model, I think. So I'm going to start showing you the instruments and the cockpit and the functions of the Airbus A320. We're going to make a new flight today. So we're gonna be overflying from Zurich International Airport, overflying Zurich, Germany and Switzerland, and then coming back to the Zurich International Airport for an Airlines localizer landing. So I'm gonna start with the primary flight display, show you the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director system panel, the barometric altitude above the sea level, the rate of climb and descent of the aircraft in tens, hundreds and thousands of feet per minute. Also the magnetic heading or track, the magnetic north pole and the true north pole, and magnetic variation depending on where we are in the world. We have also the altitude indicator, the pitch ladder indicates the bank angle in degrees, and also we have the side stick for the fly-by-wire of the Airbus system. You can see the side stick position in the primary flight display, commanded side stick position. We have also the flight mode annunciator. You can see the autopilot and the auto throttle, lateral and vertical navigation modes, and the auto thrust system. So we have also the barometric pressure of the outside atmosphere. We have also the navigation display. The navigation display displays the airports, the waypoints, the navigation aids, the GPS position of the aircraft. You can see also the terrain displayed from the weather radar, and with the weather, also other aircraft flying our own aircraft. We have the magnetic north pole and north pole and magnetic variation depending on where we are in the world. Again, we have also you can see other aircraft flying our own aircraft using the transporter transmitter receiver. Again, that displays the distance, the altitude variation, the direction and the airspeed of the other aircraft, and generates the TICA system, the traffic collision alert system advisories. We have also the flight control unit with the autopilot and the auto throttle, the auto thrust system. So you can select the airspeed selected or managed. You can select the heading selected or managed in the Airbus system. You can select the rate of climb descent selected or managed, and also the altitude selected and managed, and also the autopilot 1, autopilot 2, and the auto thrust. You can select also the landing gear retract and extend. You can select the auto brake. We have also the upper and the lower ECAM, the electronic centralized aircraft monitoring of the Airbus system. We have the flight management computer. We're gonna be create a flight plan using the flight management computer. We're gonna be input all the data of the aircraft, like the takeoff weight, the fuel on board, the taxi fuel, and the reserve fuel, and the passenger and the cargo on board. And this is gonna make calculations for the mean aerodynamic chord position in terms of the center of gravity and the horizontal trim stabilizer, the horizontal tail of the aircraft position. I'm gonna show you also the thrust levers of the Airbus and their function. We have dendens in the Airbus, so we have the manual thrust levers position, the climb, the flex MCT, the flexible and maximum continuous thrust, and the takeoff go around. We have also the side stick position. You can use the side stick for the flight control function. So this is gonna be generate an order for the flight control computers, the side stick position when you are in flight after takeoff all the way back to the landing. So I'm gonna show you also that. I'm gonna show you also the overhead panel. I'm gonna show you the electrical system, the left and the right engine drive and IGs, the great drive generators. I'm gonna show you the APU, the auxiliary power unit. We need to start the engines. I'm gonna show you the bleeder from the left and the right engine, and from the APU I'm gonna show you the electrical system. As I said, I'm gonna show you the batteries. I'm gonna show you the hydraulic system, the left and the right engine, and also the electrically pressurized hydraulic system. And I'm gonna show you the fuel tanks, the left and the right wing and the center tank. Also the other systems like the flight control computer. So I'm gonna explain the flight controls. I'm gonna show you the side stick and the rudder pedals. We use the side stick for the elevator, for adjusting the elevator up or down, for climb or descent, and the ailerons and the spoilers for bank roll, and also the rudder pedals for the rudder steering. And we have the nose wheel steering using the tiller. So I'm gonna start showing you all these things. So thank you very much one more time for joining me in this video. I'm Thomas Hatsios, the British American pilot flying the Airbus A320 214 into night flight. So I'm gonna start now showing you the systems. Also forgot to mention after that I'm gonna set up the flight management computer, a route, a complete flight plan or flight path using the flight management computer. So I'm gonna show you that. So I'm gonna input all the data of the aircraft, also the runway conditions, the runway length, if it is dry, wet or ice, the wind direction and airspeed, and also the pressure of the atmosphere, the density of the atmosphere, the temperature of the atmosphere, and the weight of the aircraft for takeoff, using the fuel on board, the passengers and the cargo. Also the runway length and this is gonna calculate the takeoff speeds, the V1, V-rotate, and the V2, the flaps position, also in the horizontal trim, stabilizer position, means of mean aerodynamic chord and center of gravity. So also I'm gonna input the departure runway, the seats, the standard instrument departures, the intermediate waypoints and fixes, and also the destination airport and runway, and the start of standard terminal arrival fixes. So we're gonna have a complete route or flight plan or flight path using the flight management computer, which is gonna be depicted or displayed in the navigation display. So you're gonna have the route over there to follow manually or automatically. Then I'm gonna make an engine start demonstration. I'm gonna shut down the engines and restart them, start the APU also. So I'm gonna show you all the systems, the fuel system, the fuel booster pumps, the fuel tanks, the FADEX, the full authorities, the electronic control computers for the engines. We have these engines right now installed, which are two budget engines, and we have the FADEX, one installed per engine, dual channel redundancy, one channel fails, the other takes over, controls and monitors and displays all the data and the functions of the engines that you see, of the turbo budget engines of the Airbus A320. We have about an hour left for this video, so thank you very much for joining me. I'm gonna start now. So you can see here we have the model of the aircraft over here, and it's the A321-231. So we're gonna be flying the Airbus A321 231 model, not the A320. As we can see in the flight management computer, we can confirm that this is the right model. So also we can see the engines. It's the CFM 56 B3. So we have the CFM, the General Electric engine, the CFM56. So I'm gonna start now showing you the functions of the aircraft. So pretty much you see the flight-by-wire system. You can see the side stick movement here. So I will show you now the flight controls. You can see I'm using this side stick here is similar to the side stick I have over there for inside the cockpit of the Airbus A321 231 aircraft. So you can see I'm having this side stick here. So you can see the side stick movement here and here. It's pretty much the same. You can use for bank rolls, also the rudder pedals, climb, descent, bank rolls, and also coordinated movement. You can leave also neutral, so maybe you have to use the better view right now. So you can see the movement here is identical to the side stick. Also you can see the side stick position here, the deflection, the primary flight display where the side stick goes. If you want to descend, if you want to climb or bank roll, right or left. So you can see also the other side over there is moving the same. I think we have the side stick priority button somewhere. So you can see the side stick deflection is proportional in my control and also in the simulation. So we fly with the arrows of Airbus A321 231 in the flight simulator X, the FSX9. So thank you very much for watching. I'm gonna start now showing you all the systems. Also you can see here we have the thrust levers. Other functions, we have the horizontal trim stabilizer. We can see the trim tab is moving here like this. So you can adjust the trim of the aircraft up or down as you fly. This is for the horizontal tail. And see how much horizontal tail trim. Also the thrust levers. So we adjust the thrust levers like this, up and down. And the horizontal trim stabilizer, you're gonna see later how much we adjust for takeoff. So I'm gonna show you the navigation in the ACAM, actually not in the navigation display. You can see the rudder trim here position, how much speed string we use up or down like this. Also the flight controls deflection, how much we deflect the flight controls up or down. You can see the elevator, and you can see the rudder pedals, and also the ailerons and the spoilers. So I'm gonna start now with the primary flight display, the navigation display, and the other systems. So we have about an hour left for this video to end. So you can see the primary flight display, you can see the airspeed indicated and the airspeed selected over here from the flight control unit. Also the primary flight display, the altitude indicator, the magnetic heading and track, and the barometric altitude above the sea level. We are 1430 feet. The rate of climb, descent, the state. Also the flight mode annunciator, you can see the nav in the altitude, and one flight director tool. So we can set maybe different values for airspeed like this. Perhaps for takeoff we need something like this, like 155 knots. Also the heading, we need the heading of the runway we're gonna use. One 36, the altitude. We can use the 1000 instead. And also the vertical rate of climb and descent. You can see this value is now different. You can also depress these buttons. You can press other. So now we have these values over here. Vertical speed, altitude, this airspeed 191, 25,000. So this is generally speaking for the takeoff settings. Also you can see the auto thrust. I told you about the thrust levers. You can see we have this button, it's auto throttle disconnect switch over here. If you press this, also we have the thrust reverse. Remove this the thrust reverses like this. Up into the reverse in case you need to slow down in the ground after landing. So maybe we have also electric, hydraulic fluid on the engines. So you see the reverse here for the left and the right engine, the N1. So you see the blocker doors are open like this. So this slows down the aircraft. So this is how you can use. Also you can extend or retract the speed brakes. Speed brakes, retract, and extend and retract. So this is only to use when you touch down for landing or you are in a rejected takeoff position. You can use this to disconnect the auto thrust. This is the zero, the idle position. So in idle you can see the engines produce about 20% is when they operate. You can see the data of the engine, the N1, which is the low speed starter inside the low pressure compressor and turbine of the turbofan engine, the exhaust gas temperature per engine, the N2, which is the high speed starter inside the high pressure compressor and turbine of the turbofan engine, and the fuel flow per kilograms per hour. The fuel on board 4,620 or 10 kilograms or 25%. Some other information. Here you can change this data here if you need. Now is the flight controls page. You can also display other switching things like the engine. So if you display the engine, also you have some additional information like the fuel use, 568 kilograms, the oil quantity, oil pressure, PSI, temperature of the oil, of the engine, of the turbofan engine, and the vibration, the wheels. So the engine here and the vibration of the N2 stage of the engine. Also the total temperature saturated, the gross weight of the aircraft for takeoff, 62,610 kilograms. The bleeder from the left and right engine, you can see how much bleeder you have, the PSI pressure. So if you use the overhead panel, you can see some instruments. You have some functions of the aircraft. So the bleeder, maybe we have a better view over here. Virtual cockpit, flight deck view. I don't know if we can zoom in. Maybe we can. So we have the flight deck view over here. We have a better view of the cockpit. Much nicer. So you can see the circuit breakers here also. So maybe we have also this cockpit, glare seat, TCAS panel. MCD view. ECAM view. So here we have it, the ECAM view I was looking for. So maybe we have a better view of the ECAM like this. So you can see the engines permanently over there. You can also see the other data here. But it's gonna take some time because it's a slow changeover between the views. So let's see the vent, cabin pressure. The electrical, you can see how much electric power you have like this. So you have the DC battery 1, battery 2. This is for the Airbus A321. So this is from the left engine. The left engine drives a generator, the IDZ for electric power, also the right engine drives another one, and you have the batteries also, and the APU generator which is gonna be available. So you can see how much voltage we have: 115 volts, 400 Hz frequency, the IDZ temperature, oil. So this is the electric, the emergency generator, essential transformer, DC1 and DC2. So the bleeder, you can see how much pressurizer you have from the left and the right engine, determined in the high pressure 165 degrees and 33 Ramer turbine and the PSI. So now we have the hydraulics. So you can see how much hydraulic pressure you have either from the left, the right engine, or the blue system, which is powered from one inside hydraulic tank. The power transfer unit, you can transfer hydraulic pressure when you lose one system, either the blue or the yellow, the left engine or the right engine. You can see the switching, hydraulics again. You can see the quantity. You can see these squares here is the hydraulic pumps, actually, this symbol. So the round is valve, this is the pump, and this is the quantity of the fuel, of the hydraulic fluid, in terms of aerospace engineering technology. So the conditioner, the APU, you can see the APU now is off, it's not running, so we can run the APU in a couple of seconds. So we have 32 minutes to go. Hydraulic fuel on board. You can see the fuel on board. So also another fuel on board. So we can see we have the fuel on board is 4,420 kilograms of the fuel flow for 7 kilograms per minute. So you can see this is the left wing section, this is the right wing, and this is the center of the fuselage. So you can see how much fuel you have in either one. You need the center more for gravity. Also you need the left and the right wing to be balanced over some limits in terms of fuel on board. So you can see we have the fuel booster pumps, these squares, the center tank, how much fuel we have in the center tank: 660 in the left and the right wing, the inner and the outer tank. You can see also these lines of the fuel flow, the non-high pressure fuel valves, and how much fuel goes in the left and the right engine, and the fuel used already. So this is the fuel page. As you can see, the wheel again. So maybe we can see one more time all these things over here, the virtual cockpit, but not so good view. So you can see the pressure of the cabin here, and the outflow valves, the bleeder, the left and the right engine. how much bleeder you have. Again, the way we see it before, this switching always the engine, the bleeder, the electrical, left engine, right engine, the APU also, and the battery, the voltages and the frequencies. You can see how many hertz you have. You can see the flow diagram here of the electric of the Airbus A321 231 model. The fuel on board. You can see the left wing, the right wing, the center tank, and how much fuel runs right now to the engines. The APU is off also, and the total fuel on board. So we have about the flight controls, the conditioned air, the condition, the engines, the hydraulics again. You can see how much hydraulic pressure we have, green, blue, and yellow, and the rammer turbine. So we start, the APU now is off. I believe we can start it in a couple of seconds. You can see the wheels again. So we can come here either this way or this view. So we have the overhead panel view now. We can see we can start the APU here. So this is the switch to start the APU and the start after it takes a few seconds, I think. You have also the bleeder, left and right engine, the APU. I'm gonna show you later in the engine start, the electrical, left and right engine. So maybe we can go now. Let's see here. That the APU has started already. You can see the APU, the flap open. We can turn off the APU, gonna say. See, turn off. The APU is off. Now we start again, one more time. So this is a smaller turbine we need in the back, in the tail of the aircraft. So we start the APU. So we are almost ready to start the engines. Maybe we have a few more minutes left for that. So we have 40. So we have about 48 minutes left for this flight. So it's a good time. You can see also we have another aircraft here. Maybe we can display. I think we have to use the TCAS on. So we're gonna have the display here, other aircraft traffic advisory. You can have the terrain on the display you need. It's gonna be simulated later in another version. So I believe we can so a few more things. You can see the trim wheel, gives us the pitch attitude. We have the climb. I'm gonna show you now some of the thrust of the engine. Clear on the engine here. You can see the climb continues, the maximum continues thrusting. So this is how you adjust the engines, and you will see the engines climb continues 81.1%, the exhaust gas temperature into fuel flow, and also the flap settings. You can adjust the flaps up and down. So you adjust like in the position, the full, you will see the full extent here. So you will see the flaps extend fully here. So I will talk to you now about maybe the flights here of the aircraft. We have also the speed brakes. You can extend this also. You can extend to about half if you need. You are in flight. The parking brake here. And the radio and communication panel, and also the flight management computer, the CDU. So for this aircraft we have about 60, I believe we have it here, 62,000. We have about 62,000 kilograms for takeoff weight. The Airbus A321 we have about 4,200 kilograms of fuel on board. So we're gonna need to use about flap settings of 1 or 2. So we're gonna need also a takeoff speed for this runway conditions, this runway length, the National 14. The temperature of the air, the pressure and the density, and also the airspeed component, the direction of the air. We're gonna need about 150 knots or 155 approximately, or about 270 kilometers an hour, or 150 nautical miles per hour for takeoff. We need to overcome the stall speed. The stall speed is gonna make the wings of the aircraft stall and not produce the necessary lift force for takeoff. So the airflow of the air as the aircraft accelerates using the engine thrust. So the thrust from the engine overcomes the static and the kinetic friction, and the lift from the wings overcomes the weight of the aircraft, that is equal to the mass of the aircraft times the acceleration of the Earth's gravity, depending on where we are in the world. Also, the airflow of the air mass as the aircraft accelerates to the takeoff creates this aerodynamic lift component, lower pressure above the wings and higher pressure below the wings. So I'm gonna show you now some principles about the outside view of the aircraft, and I'm gonna explain the Newton's first, second, and third laws, kinematics of motion, and the Bernoulli theory of fluids, also aeronautical and aerospace engineering quizzes for the pilot license. So we need to derive some equations, make explanations. So I will show you now these. So you can see here, so we can see, you can see that the surface area of the wings holds the weight of the aircraft in total in terms of aeronautical engineering. Or you can see also we have the mean aerodynamic chord position, 25% of the Mach, about here approximately, from the forward leading edge. This is the mean aerodynamic chord where the maximum aerodynamic lift occurs above the wing. It's also the position where the center of pressure of the air above the wing, and also where the stall above the wing, the airflow of the air mass becomes detached from the top surface of the wings when you have a stall in an aircraft. So it's also where the position of the center of gravity is being located for most aircraft. You can shift it forward or after this position by shifting passengers and cargo and fuel inside the aircraft. You can see we have the leading edge and the trailing edge, the airflow of the air mass. So you can see the bottom surface of the wings is more flat, generally speaking. So as the aircraft accelerates for takeoff, the airflow moves slower below the wing, so we have higher air pressure below the wings, which lifts the aircraft up into the air. Also above the wings, we have higher airspeed. So this is the Bernoulli theory. So the airflow is moving slower below the wing, higher air pressure or positive air pressure pressurizes the wings of the aircraft up into the air. Also, the airflow of the air is moving faster above the wings, so we have lower air pressure above the wings. So we have negative air pressure, which sucks the aircraft wings up into the air. You can see the engines, the CFM, the General Electric, the turbofan turbojet engines, which propels the aircraft forward. You're gonna see the engine start later. You can see also we have the moment arm or lever arm. The moment arm is times the distance from the center of gravity all the way back to the horizontal or the vertical tail. So you can see is times the distance from the center of gravity all the way back to the horizontal or the vertical tail over the surface area of the horizontal or the vertical tail, times the airflow of the air mass per second, times the Earth's acceleration of gravity. So you can make a force to pitch up the aircraft or pitch it down, or make turns left and right by deflecting the airflow air mass using the center of gravity. So we have this vector is the longitudinal vector from the nose to the tail of the aircraft. This is the vertical axis or vector through the center of gravity, and this is the lateral or axis from the wingtip to the wingtip. We have also, you can see moment arms by deflecting airflows in the left and right wing. By moving the side stick left and right, you can make turns like this, so you can steer the aircraft in the air. Also you have the ailerons here and the spoilers for making turns. Not so much well viewed like the Boeing, but you still have it. So I'm gonna show you now the flight controls. So now I'm gonna show you the flight controls, and we're gonna make an engine start demonstration. I'll just show you the flight controls before I believe it starts. You see again we have the same things, the side stick again. So you can see, as I explained to you for the flight theory, you can shift the side stick around like this. So the rudder pedals, you can see the side stick position is proportional. Over here you can make bang rolls left and right. Also see the pitch attitude over there. So now we're gonna make an engine start demonstration. Turn off the engine. We have the APU off already, so this is gonna take a few more minutes, a couple more minutes, and we're gonna make the engine start demonstration. We'll set up the flight management computer, the 3D view, so you can see also the outside view of the flight control side stick deflection again. One more time. Here and here. So you can climb, you can descend, also make turns. So I'm gonna make now the engine start demonstration. So we can turn off both engines by turning off the fuel flow for the left and the right engine. You can also see we use like this, turn off both engines in the off position. We're gonna lose some systems, some flight controls. The APU is on, so it keeps running the engines. Oh, here we have the engines. The aircraft. We have the wingtip. The wing view. So here we have the engine shut down. We need to restart very quickly. So we have again over here. We need to come in the overhead panel. We have the bleeder like this. Maybe you bleed on like this. Because the APU is on. So also we need to turn on the FADEX to the start position like this, and this is gonna be automatic with also like 4 minutes like this. We're gonna have pressurizer, so we admit I believe the engine 1 first or engine 2. So we're gonna start the engine 1. So you can see here we have the engine 1 start, and we have the hydraulics on again. Now we're gonna start the engine 2. So you can see the engine 2 start process. And we have the engine 2 also start like this. So we go back. We have started both engines. So now we need to do one last step. Just set up here the CDU, flight management computer. So we have the data, aircraft status, the fuel prediction, zero fuel weight, gross weight, and the fuel on board. $4,000, so it's minus for 3,800, it's about 57,000 approximately. We enter a block fuel 57,000. So we have the initialize from Zurich International back to Zurich International Lszh. Align the IRS 35,300. Flight plan from this departure over here. Select a departure. Lszh to alpha, insert, and arrival. Lszh transmit on alpha, insert. So we have the discontinuity, clear the discontinuity, direct, and the takeoff performance. And we have the takeoff speed. We need 124 knots. So we're gonna use 1, 2, and we have the flight plan, I believe, and everything is set here. The flight plan. We're gonna see the flight plan here. Been created. We have the route. Everything is ready for taxiing to the runway. So we just need to taxi into the runway, and we have like 18 more minutes to go. Disarm the parking brakes, advance the thrust levers forward, and use also the tiller for steering. So we took the runway clearance over here for takeoff. We have again, the runway is clear. We need only to taxi to position for the takeoff. You can see we use the rudder pedals for steering. So we have about we need also to have a better view. So this better view. We just need to advance the thrust levers. We have everything set, and disarm the parking brakes, and we go. So we have 50 knots. You can use the rudder pedals for steering. 90 knots, 100 knots. V1, we rotate, we start to rotate. Here we go. Rotation and climb. Landing gear is up. So we have the positive rate of climb, and we have like we have about 15 more minutes for this flight. So we need to climbing. You see the primary flight display. You see the airspeed indicated. We are 1,000 feet above the ground level, 2,700 above the sea level. We climb with 2,300 feet per minute, and you can see all the modes. This is a bit different than the Boeing in terms of how it flies. It's, I think, a little bit more reactive in the takeoff, and the landing, but it's okay. So we keep turning. We're gonna have a nice view here. So we're gonna follow these steps here. We have about 14 more minutes for this video to end. So we're gonna have the view of the Zurich here, the Switzerland. Also we have the beautiful view of the sky, the galaxy. So you can see how the side stick reacts in my turn commands. We keep climbing. We have the takeoff go around, maximum takeoff go around thrust. We can use this for a couple of minutes only. We have to move this back to the climb to continue the climb process. Also, retract the flaps to increase the airspeed. Flaps down again. You can see here we have the stall speed, the warning where the stall speed occurs. So we're gonna need to make stall avoidance in case you use more flaps like this. So we need to follow this this rate of climb over here and this waypoint. We need also to level off for a couple of seconds. Leveling off. And change the other direction. So we're gonna have the German in front of us in a couple of seconds as we climb. We're 16,000 feet. It's slower actually, much slower than the Boeing in terms of the Boeing 777 in terms of climbing. So this is the Airbus A321. You can see also we have the beautiful view. We have the Lake of Zurich. Here we have the Germany, the Bayern Munich in front of us. We have about 8 minutes left for this video to end. Keep climbing. 18,000. I believe we need to start turning back to our airport now, because we have only a couple more minutes left. So here we are, we're going back into the airport. and we have like 8 more minutes left. So we cross here the Bayern Munich area. Behind us the Germany and the France, and we over find Switzerland. We have also the galaxy here, this beautiful galactic view. 20,000 feet, 20,800, 900. We need to cross the waypoints much faster. 31. So we keep climbing. 31,800. We should have used the takeoff ground power for a faster climb. 32,000. We're very close to the stall speed now. We need to level off. We're gonna have the chemtrails in a couple of seconds as we climb. So here we have the chemtrails, and we have like 6 more minutes left for this flight. So this is the beautiful chemtrails, the frozen vapors, as you can see, as we cross the sky here in Switzerland with the Airbus A321. We need to start descent now. So we're gonna have one more flight with us. You can see the frozen vapors as we go back. For landing, so we need to start our descent in a couple of seconds. Also retract the flaps. So here is the chemtrails, the frozen vapor, as you can see. And we start the descent process. And we have like 5, maybe more minutes left for this video. So we move the thrust levers to the idle, and we start the descent. Also the airspeed for landing and the altitude there. So we are 13,000 feet. The landing gear is down, and we have 4 more minutes for this flight to end. So we keep descending. Also need to increase the flaps again. We need to make a shortcut for the runway maybe. Also the flaps. So we have 3 more minutes left for this flight. 3 more minutes for the video to end. Sixteen, 17, 18, 'So here we are. Thirty, 10. Here we are, parking brakes and reverse thrust. Full reverse. Full reverse thrust. And we just touched down in the runway. And we have 1 more minute left. So you can see we made a very nice smooth landing with the Airbus A320. You can see the nose wheel here is perfectly safe. There is no breakage of the nose wheel over here, or the metal parts or struts. Also the landing gear behind. You can see all the wheels are perfectly normal, and the left and the right wheel, there's no breakages. So as I told you, the front over here, this metal part, no braking, not like some other pilots are doing when landing their aircraft. So we can also exit the runway here in a couple of seconds. So that was all for this flight.